So next we have a talk by Nithish Chandra Reddy, one of the few student talks in this ROSCON. So big round of applause for him. The talk is about ROS1 and ROS2 profilers for computational analysis.
Oh, hi everyone. Can you please wait a second? Yeah, I'm sorry for that. Hi everyone. Glad to be here and honored to be. Room full of brilliant people here. I want everyone to stay alive for next 10 to 20 minutes, so that we can have tea break after that. I'm actually waiting for the break so that I can have free cookies. Yeah. So that now I have all your attention. I'm Nitish here with my friend Pranay. We are from GITAM University, which is located in Dodbalapur, Bangalore. We have recently established a lab which is under Murthy Center. Uh, Let me show you a video instead of telling about it. Yeah, can I have the video, please? Yeah. Those are the few cool things that we are doing lately. Yeah. Let's see what are we. I wanted to show that video so that you will know where are we at actually. We are here to show you our own custom profilers for computational analysis. Our work specially focuses on comparison of 2D and 3D SLAM algorithms. So I hope everyone are familiar with this SLAM concept. So the people who are new to this concept, SLAM is simultaneous localization and mapping. Um, it's basically creating an environment around the robot and telling the robot orientation and direction of the robot in particular map. Yeah. So as you can see, multiple SLAM algorithm names on the screen. So which one is the best? So this is the question that led us to present your work here. Before diving into it, let's know what was the journey. I would say it's a struggle. So our initial goal was just to map our environment entirely with the using lidar data. So we have a similar. I guess you have seen the video. We have a buggy which is integrated with all the sensors, lidar, camera, and also the compute, and with the defaultly implemented SLAM algorithm in it. So on top of that, we wanted to try out other SLAM algorithms which are existing in. So for that, we had to learn ROS. So there is a lot of terminology we had to adopt. It was not easy initially to understand the architecture of ROS. So yeah, somehow we managed it, and we are now able to create our own nodes and packages which can be pushed to the ROS. So sadly, we know that ROS one is going to end next year. So we are also in transition to ROS two. So learning ROS was not the end of the story. We wanted to try out and test whether our algorithms work properly. We wanted to try out in the simulation mode. For that, our PI, who is sitting here, suggested us to learn Gazebo. Then I was like, "Arey yaar, I have to learn one more new framework existed. So, but yeah, somehow found interesting, and I found Gazebo is very versatile. So we can have actual real world dynamics to the robot and also to the environment, so that we can see how the robot is interacting to the environment. And the next step is to dump our code to a buggy. So this is the maze we have created in the Gazebo. We The reason we have created is it has all the rigid and proper shapes, and also the narrow ways and wider ways, so that we can easily see which algorithm can be able to map it properly. But surprisingly, everything looks the same, right? You can see G mapping, Hector, Carto, and frontier exploration, 2D SLAM algorithms. So by seeing them, we can say everything looks almost similar. Yeah, this is a 3D one. We have collected data sets from the internet, and we have tried out with all the different types of SLAM algorithms. Uh, can you say which one is a better SLAM algorithm by seeing the screen? We cannot say, right? Humanly, it's not possible. I asked Pranay. He said DLO looks fine for me, and I said no. Leo Sam is the best one. So that debate went for an hour, I guess. And then we thought, why not calculate it mathematically? So Pranay came up with the idea of let's create a node. So the logic behind our profilers will be explaining by the Pranay. Over to you, Pranay.
Hi everyone. So with this knowledge of ROS and all the packages, all the nodes, launch files, so we come up with an idea like let's create a node to systematically say which SLAM is the best one, like benchmarking the SLAM algorithms based on few matrices based on CPU load, RAM usage, and computation time. So let's see the logic of it. So computational time. So in this, we leveraged a Python PSUT library to get resource processing and system utilization values from with those library. So when we are launching a file, when we initially we have an idea that we need to get those values, but how? Because in the system we usually run multiple hundreds of things in the background. It will be going to run, so it affects our result if we give that proper, if you give that values and running that SLAM algorithm. So we thought of looking at topics. When we launch a SLAM file, there was a all set of topics which was publishing, and we observed that. And there was a back file which recorded the data, so that when I launched that black file, there was a topic additionally adding, that is a clock topic. So based on that, so why can't we use that topic to start measuring those matrices and give results of it? So initially we created a node and we just launched it through the launch file. So based on that clock topic, we will be starting the recording of that parametric values. So once the clock topic is detected, there was a stop, like CPU, initial CPU and RAM, which is collecting there. So it stores that values. After that, it's subscribed to the topic and continuously takes the values until the back file completes. So when it's taking at every iteration, we will be getting the how much CPU and RAM value. And here we computation time. Here the computation time, what we focused on is like the scan to scan matching for a map to get understand. It's not about the back duration file. It's about the scan to scan matching, so that it gives a better understanding how quick the SLAM is going to map the given back file. So with those, it loops continuously, and it after it at every iteration it monitors whether the clock topic is present or not. If it is deactivated, then it's get stopped, and it logs the average values of all the iterations and gives the final result of what's the CPU load of current SLAM, RAM, and the computation time of it. And this is the logic of mapping accuracy. So the basic first challenge what we got is like, okay, like you before in the videos you have seen the 2D SLAM where we have created in the gazebo environment. So we have a ground truth image so that we can easily get accuracy of map and ground truth comparing of both those maps. So whereas 3D backfiles where we tested with available backfiles through the Git and also recorded backfiles in our lab. So for that, we need some metrics to calculate how much accurate or the map is. So that what we come up with an idea, same again with the topic of called map, we created a Python script to save the 3D map as a PCD file, and those are the two PCD files of same back file. So we consider those PCD files and taken and overlaid on them how much we checked, like based on the RMSE values, we checked how similar those maps are of the same environment. So for the 2D map, it's very much easy that so that we have a ground truth image and we have a map image, so that we just overlaid on them and just pixel by pixel matching. It's a basic one to get to calculated, and we just given a accuracy value of it. So, and these are the results of those SLAM algorithms. So when it comes to G mapping, it was a lightweight, and it is used in very less resource availabilities. If we have a resource constraints very much limited, then we can go with the G mapping. Whereas Hector and Frontier explanation gives the best accuracy, best mapping accuracy. So in some of the application, we need exact map accuracy so that we can go and do that one. So Carto has a balance between the resource efficiency and processing time, so that in the so it depends on us, like what all the resource limited. If we have a limited resources, then we can select these are some of the slams if we are using 2D slams. If you have a higher resources, then we can go with the good slams. So these are the results of 3D slams. Whereas Fastlio it processes the slam and it completes the process in quicker way when compared with other slam algorithms. So if any application we require the map immediately within a short time, then we can move with Fastlio. And FLOM is you can be used in memory limited constraints and memory limited systems. So ISCLOM and LeoSam has its highest computation efficiency because they're taking high CPU and RAM usage. So they can be used in mostly not in the product development side, can be used in the research purpose when you are developing all the things.
So adding points to Pranay. So to conclude this, Pranay is trying to tell that based on our constraints and our applications, we can choose after using our profiles, we can easily have a benchmarking. So with this, we can, according to our constraints, like let's say I don't want high, what do you say? I don't have much resources, and I want the SLAM algorithm which takes less resource. I mean, less RAM and less CPU, gives a less load. So I can go with the algorithm which has that performance by seeing the graphs. So this to conclude, it's not only we can use for SLAM algorithms, we can also use for different types of packages with slide modifications. Yeah, this is one of the thing that we did in lab, and uh, we are also we are now a small team and looking forward to have a big team with the help of you guys. And can we have a QR code? Yeah, please check out our website, and to connect you can scan last QR code, and this is the Git repo of our work. That's it. Thank you very much for listening patiently. Thank you.